In this video, we are going to learn about the activity selection problem. Activity selection problem can be solved using greedy approach, and it is one of the application of the greedy algorithm which has already been explained in the previous lecture. Now, let us see in detail about the activity selection problem. The activity selection problem is an optimizational problem concerning the selection of non-conflicting activities. What is non-conflicting activities is they exist together in a way that does not cause any problems between them and they perform within a given time frame. Given a set of activities, each marked by a start time denoted as SI and finish time denoted as FI. So now let us consider that you have n activities with a start and finish times. The objective is actually to find the solution set having a maximum number of non-conflicting activities that can be executed in a single time frame, and assuming that only one person or machine is available for the execution. So this is basically what is activity selection problem. These are some of the points you should remember while handling with the activity selection problem. First point is, it might not be possible to complete all the activities since their timings can collapse. And it also says that two activities are said to be non-conflicting only if Si greater than is equal to Fj or Sj greater than is equal to Fi. Si and Sj is the starting time of the activity and Fi and Fj is the finishing time of the activity. So finally it says that two activities are said to be non-conflicting only when starting time is greater than is equal to finishing time. And it finally says that greedy approach can be used to find the solution since we want to maximize the count of the activities that can be executed. Following are the steps we will be following to solve the activity selection problem. The first step is to sort the activities according to their finishing time in ascending order. The second step is to select the first activity. The third step is the selection of the new activity. By repeating the step 3 till all the activities are checked, the activity selection problem can be solved. Let's try to trace the steps of the above algorithm using an example. In the table below, we have 8 activities with corresponding start and end time. The objective is to compute an execution schedule having maximum number of non-conflict. So starting with step 1, we have to sort the given activities in ascending order according to their finishing time. Have a look at the finish column, that is the column in the previous slide. The least value is 2, which belongs to activity 3, that is A3. So we will write it first. And the next value is 3, it belongs to A1. And then we have 4, which belongs to A2. So in this similar way, we have sorted out the table in the ascending order in this slide. So this is the table we have sorted out. Step 2, select the first activity. It says that the first activity is kept as it is and we are going to solve the rest of the activities using the condition. As of now, the first activity is A3 for which the start time is 1 and the finish time is 2.
So let us solve this table. As already said, the first activity A3 is kept as it is. Now let us take the second activity A1. 1 greater than is equal to 2. Why we write like this is we have the condition like start time should be greater than is equal to finish time. So this is the condition for the activity selection problem, like 2 is the previous finish time and 1 is the start time. 1 greater than is equal to 2 is obviously false and it fails, so the activity A1 is not selected. Moving on to the next activity, A2, 0 greater than is equal to 2. It is also false and this activity is also rejected. But here we have to note one point, like we are choosing the previous finish time 2 again here, because we have like only if this condition is satisfied we should select J, or else we have to choose only the first finish time. Now moving on to the third condition, third activity, 3 greater than is equal to 2 again. Because 0 greater than is equal to 2 is again failed, we are taking the same finish time as 2. So this condition is correct, so the activity A7 is selected. Now we are moving on to the next activity, that is A8, right? Yeah, 4 greater than is equal to, now we have to write 5 here, just because 3 greater than is equal to 2 is chosen, that activity is chosen, so that finish time we should not write here, so we are writing 5, the next finish time. Like before A8 activity we have 5 as finish time, so 4 greater than is equal to 5 we have chosen, so the condition is failed, so obviously A8 is not chosen. Moving on to the next activity, there also the same condition, A4 is also rejected. And then we are taking A6, that is 5 is the start time again, greater than is equal to again 5, the previous finish time, because previously 4 greater than is equal to 5 is failed, so here we are choosing the same finish time and here it is satisfied, so the activity A6 is chosen. And finally A5, the last activity, 2 greater than is equal to 8. Because 5 greater than is equal to 5 is satisfied, the activity is chosen. So we are choosing the finish time as 8 here, but that condition is failed, so A5 is not chosen. So this is the way we have to solve the activity selection problem. For the condition start time greater than is equal to finish time, we have solved this table. So finally the activity which satisfied the condition is A3, A7 and A6. So that's all is the activity selection problem.
So yeah, this is the final output, A3, A7 and A6.